and let's carry on for the second part. Let's delete this. Okay, today we're gonna see this beam. Here we have point A, we have point B, we have point C, and we have point D. So from A to B 3 meter, from B to C 2 meter, from C to D 1 meter, and we have the beam is supported at A and D. The other thing is from B and C, from point B to point C, there is a uniformly distributed load which has a quantity of 30 kilonewton per meter. So be with me, and we're going to solve this also with SolidWorks. The other thing is we have one link and 2 and 3, right? So AB, BC, and CD. Let's go. Let's file, new, sketch. So 1, 2, 3, right? Sorry, before that, let's change this thing to meter. And let's edit it. Let's edit this. So 3 meter, 2 meter, and 1 meter, right? So how much is this? Let's make like this first. This one and this one. This one was 3 meter, and this one is 2 meter, and the last one is 1 meter. Let's exit. As we always do, let's go to weldment and let's structural member. Let's select the whole thing. Let's click. We don't need this. So let's go to the sketch of this rectangular tip. Let's select this and let's delete. So let's draw our own beam. Let's make it like this. And let's change this. This is, I think, in Z and in the Y. We want it to be in this one in the X, this one in the Y. So let's edit this and let's rotate 90 degrees. Okay. Let me rotate it. Plain white. So let's go to simulation and let's say this beam analysis 4. So as we always do, let's assign a material, and then let's go to fixtures and let's fix. As you can see here, we have the joints, right? Let's make like this. We have point A, B, C, D. A, B, C, D. So let's apply the reaction forces, point A and point D. Let's apply the reaction force, and then we will apply the uniformly distributed load, and then after that we'll go into our simulation. This one is the joint, right? And the plane is going to be front, and then we're going to apply the reaction force. Let's increase the size of this arrow. This like this, right? Okay, carry on. Let's continue to the point D, and let's make this point D, and from plane, and then we will have this upward supporting force, which is 500. I don't mean the load, but what I mean is the size of the arrow in order to make it more visible, because this is too small. We have to increase this to what number we want. The maximum number is 500 here. As you can see, it's more visible. And then let's apply the load. Okay, let me see. 30 kilonewton. From point B to C. It means from this to this. So this is the beam. Let's choose this, and it's gonna be in the front plane, this downward direction. So let's check this per unit length. Let's apply the load. How much was it? 30, right? 30 kilonewton means 30,000. Okay, let's reverse the direction, and the same thing. Let's increase this. As you can, this is too small. In order to make it visible, let's make 300. Right? This is our way. You know, as you can see, this thing is now transformed to this thing in SolidWorks. Now what we left is to run this study. Let's run it. This is right. So let's go and see the reaction forces first. This one at this point and at this point, then update. As you can see here, it means 20 kilonewton. This one is 40 kilonewton. So let me see, 20 and 40 kilonewton. We are perfect, okay? Bear with me. And let's see the shear force and bending moment diagrams. The shear force, let's make this 300, the radius of the beam. And the other thing is, let's tell them to show us the maximum and the minimum. Let's make this one and float in. In order to easily move this thing, I think. This is the thing, right? So as you can see, we have this 20 and 40 kilonewton. As I always say, 20 and 40 kilonewton. This is the sign convention. This one is the first, right? As you can, this one. And let's go for bending moment diagram. This one, and let's make this 100, and let's show us maximum and the minimum. Right click. This is the thing, guys. I hope you are enjoying 66.67, right? This is 66.67.